There is a saying that you can solve one problem in many ways, but some problems, like the one we have here, some problems can be solved only if you find what have been already found. You have to find an ingenious idea, an ingenious method to solve these type of problems. So let me show you how a creative approach, an ingenious idea can help you solve these really hard problems in a very elegant manner. So if we directly square this equation, we will get a fourth degree polynomial equation. And let me write that down, the fourth degree equation that we will get. And the equation will be x raised to the power 4 minus 26 x squared minus x plus 156 equals to 0. You can square both sides and we will get this equation. The problem with this equation is that this is a biquadratic equation and we don't have any formula or any idea to solve this question. The terms are not symmetric, so we cannot use any known trick that we have. You can give it a try. I have tried it. It's not easy to solve. So what is the ingenious out of box idea to solve this question? Let's see. What we are going to do here, first let me write what we have. X square minus 13 equals to square root of x plus 13. So instead of using the number 13, I'm going to use a parameter a here. So instead of 13, I'm going to use some kind of parameter. Let me call that parameter p. So we have x square minus p equals to square root of x plus p. And for our problem, we will substitute p equals to 13 in the later stages. Let's try solving this problem. Let's square it. So we will get x raised to the power 4 minus 2p into x squared plus p square, and right hand side will be simply x plus p. We can rearrange the terms to get a better looking polynomial equation, and we will get x raised to the power 4 minus 2p x squared minus x plus p square minus p equals to 0. We again have a biquadratic equation and we don't know how to solve it. But if we think out of the box, we can see that if we think with respect to the parameter p, we don't have a biquadratic equation. We have a quadratic equation in terms of p. So let's try thinking about the quadratic equation that we have in hand. Let's try to solve it. In terms of p, we have p squared term, then we have some terms of p. Let's see what do we have. We have one term containing 2x squared and another term containing 1. So 2x squared plus 1. And the remaining terms can be written as x raised to the power 4 minus x. So this was the out of the box idea, that we have converted an equation which was looking like a fourth degree equation into a quadratic equation in terms of our parameter p. And we can solve this quadratic equation using a very simple quadratic formula. First, let's evaluate the discriminant of this equation. The discriminant is b squared minus 4 times first term, first coefficient into last coefficient, 4ac. And we can simplify it. 4x squared plus 4x plus 1 minus 4x raised to the power 4 plus 4x. Let me correct the mistake that I have made. This is 4x raised to the power 4. We can cancel out these two terms and we will be left with 4x squared plus 4x plus 1, and this is nothing but a perfect square of the expression 2x plus 1. So our discriminant is coming out to be 2x plus 1 whole squared, which is a really nice looking expression. And we know that if discriminant is a perfect square, finding the roots of the equation becomes very easy. So let's apply the quadratic formula. The values of p will be, we will get two roots, minus b, that is 2x squared plus 1, plus minus square root of the discriminant, which is 2x plus 1 whole squared, divided by 2. And let's simplify it. 2x squared plus 1 plus minus 2x plus 1. So we are getting two values of p as expected, and we can simplify this expression. Upon simplification, we will get one value of p as x square plus x plus 1 when we take the positive sign, and when we take the negative sign, then we will get p equals to x squared minus x. Now, with respect to the problem that we had, the value of p was 13. So for this particular problem, we can substitute p equals to 13 to solve this. And the brilliant thing about this solution is that if we substitute p equals to 13 at the later stage, at the stage that we are right now, we are simply getting a couple of quadratic equations which can be solved very easily. X square plus x minus 12 equals to 0. This is the one quadratic equation, and the other one is something like this. And we can solve this one very easily. We can factorize it. X plus 4 multiplied by x minus 3 equals to 0. And we will get x equals to negative 4 and x equals to 3 as two solutions from the first quadratic. Second quadratic cannot be factorized directly. We can use the quadratic formula here. And we will get x equals to 1 plus minus square root of discriminant, which is going to be b squared minus 4ac over 2. So these are the values that we are getting. X equals to negative 4, 3, and the two values from here are 1 plus square root of 53 upon 2, and the other value is 1 minus square root of 53 upon 2. Keep one basic thing in mind, that in our original equation, this was the original equation. So we have to be careful that the values of x that we are getting, they should be greater than or equal to negative 13, because we cannot have a negative number inside the square root. So we are getting four answers, but out of these four answers, you can see, so we have to reject these negative answers that we are getting, and the valid answers that we are left with are x equals to 3 and x equals to 1 plus square root of 53 over 2. These are the valid answers. These are the correct answers. So this was a really tricky problem, but once you know the basic idea, the basic trick that we are going to use to solve these kind of problems, the solution is really elegant. I hope you guys like the video as much as I like making it, and I will see you around in the next video. Don't forget to subscribe the channel and have a very nice time.